Giving shape to ideas. Konica Minolta.
This video is a demonstration of the CM-700d Portable Spectrophotometer from Konica Minolta Sensing, a vertically orientated measuring device with a small 3mm aperture and a medium aperture of 8mm. By extension, also the CM-600d, which is physically and functionally similar, but only with the medium measuring aperture. As portable spectrophotometers, these devices excel at measuring the colour of solid samples, and the vertical orientation reduces the operator's strain if the device is used for longer periods. The CM-700d can be used in standalone mode using the onboard display and control panel, or connected to SpectraMagic NX or the Calibri computer colour matching platform via Bluetooth or via USB cable. To begin with, I'll measure these neutral cream coloured plaques. To begin with, we can look at the design of the standard aperture plates included with the device. The aperture plates are supplied both with and without a stabilising base. The stabilising base provides stability on flat samples, and stability onto the sample means improved repeatability of measurements. And the aperture without the plate is better for small, curved or concave samples. In this clip, I'm using the 8mm aperture with stabilising plate. The L star, A star, B star colour data is shown along with pseudocolour. As this is the first measurement and we'll use it as the target, no colour difference information is shown. Using the display and the built-in controls, it is possible to access essentially all of the configuration and operation settings as you would through the software. Here, I'm using built-in controls to name the sample for easy recall and analysis. Measuring the next plaque as our first sample, you can see that the display turns green to show that this sample is a pass using the current tolerances. Using the onboard controls, it is possible to view the colour and colour difference data in a number of ways. You can see that this sample is very close to the target, with a delta E of around 0.1. Should you wish, it's possible to set different tolerances, either for groups of targets or on an individual target by target level. Moving on to a different sample. This item has both texture and contours. In real-world use, we would recommend that you establish a consistent site on the sample to control for the contours. You may even use averaging and measure a single site at different angles, by which I mean rotating the measuring head of the device. There are other things that you can do to assist repeatability, depending on the opacity of the sample. For example, moulding a jig that would provide a solid black backing to the sample at one or more points. As always, we would recommend that you experiment with different approaches to maximise repeatability whilst maintaining time and cost effectiveness. Your local Konica Minolta Sensing office and application specialists can help you with this best practice. I have switched to the small aperture plate without stabilising foot in order to maximise contact with this contoured sample. The vertical orientation of the device also means it's a little bit easier to control contact with the sample. Once again, this data is displayed in a number of formats. For the next measurement, I will use a Bluetooth connection to the SpectraMagic NX software. I'm using a custom template. Custom templates are a feature of SpectraMagic NX, allowing you to configure your own report layout or measurement screen. If you have SpectraMagic NX already and you haven't managed to get a template that quite suits your needs, then please do reach out to your local Konica Minolta sensing office. Some small changes can make a huge difference to the operability of the system and the value of the reports that are generated. You can see along the top colour difference information, instrument information like serial number and service due date. In the middle, an LAB plot and pseudocolour and a trend graph, and on the bottom, the spectral reflectance curve. This is a really challenging sample with texture, curvature and gloss. Both in standalone mode and connected to the software, the device can utilise average measurements, averaging any number of measurements into a single data point. Averaged measurements show mean and standard deviation and allows the operator to omit any outliers. Whilst in day-to-day use for QC, we want to establish quick processes that are still accurate. For some samples, it is invaluable. Even averaging 3 measurements will smooth out outliers and small measurement errors. When colour, much like when observing colour, the surface gloss impacts what is measured or seen. The CM-700d and CM-600d measure specular component included, SCI, and specular component. The specular is the direct reflection of the illuminant, and glossier surfaces act like a mirror, with a strong and directional reflection of the illuminant, where matte surfaces diffuse the illumination to a greater extent. So, a simultaneous measurement of SCI and SCE helps to quantify the impact of the surface on the surface appearance. This isn't the same as a gloss measurement in GU or gloss units. For a spectrophotometer with an integrated gloss sensor, see the CM26DG. This sample is a plastic packaging for the personal care market. The lid and body are colour matched but have a different surface finish. This can be examined by measuring with SCI and SCE. Measured with SCE, the colour is measured with a noticeable difference, where the reflection of the matte surface measures lighter and more vivid colour. The strong specular reflection on the glossy surface is excluded. The lid therefore measures darker. The finish is impacting the colour that we see. When measured with specular component included, the true colour of the sample is a closer match. As none of the reflection is being taken away, both the tub and lid include the entire reflection. To provide only the most basic of explanations here, a mechanical light trap lets the directly reflected light escape the sphere without being measured when making an SCE measurement, whilst the trap closes and integrates that directly reflected light into the data for an SCI measurement. For more information on colour measurement and colour theory, including why and when to measure specular component included or excluded, please see the resources on the Konica Minolta Sensing website Learning Centre. Your local product specialist will be happy to offer advice to help you develop the best solution for your application.